Assalamu alaikum. So this is the continuation of the lecture we had on mechanics of machine last time. So in this lecture, uh, we are continuing to discuss some of the aspects we have already covered. So the kinematic chain, the types and examples. We have done some of the examples kinematic chain already. Uh, so this one is little bit more in detail for the topics which has already been covered. So what it says the most important kinematic chains are those which consist of four lower pairs. So of course there are a variety of different mechanisms which we have studied in last lecture from Theory of Machine and Mechanism by Shigley, and that has included those mechanisms from one of the research paper, Profession. There were a variety of different mechanisms, but among those, some of them are quite important, including the one which has four lower pairs. So, as said last time, we had a brief overview of those mechanisms already. But now in this lecture, lecture 3, we are dealing a little bit more detail of those mechanisms, only those mechanisms which are more of practical use for mechanical engineering applications. So among those classifications, the one which has four lower pairs are basically considered a more appropriate or more useful for the mechanical applications. So again, the most important kinematic chains are those which consist of four lower pairs, each pair being a slider pair or a turning pair. So it could be anything, like those lower pairs could be a sliding pair or a turning pair. So the following three types of kinematic chains with four lower pairs are important from the subject point of view. So we got one of the example is 4-bar chain, which is sometimes called as a quadratic cyclic chain as well. This 4-bar chain, because we got four, so quadratic is four basically. Then we got a single slider crank chain. So you might have remembered the slider crank mechanism is already a 4-bar chain. Basically 4-bar is a similar thing, but here we are doing a little bit of more different classifications. That's why this has been discussed separately, and a term single is being introduced here because there is a possibility where you got a double slider as well. So that's why this will be another classification. So this time in this lecture we will discuss a little bit of more detail for each mechanism. So continuation of that, we got one of these 4-bar chain or quadratic cycle. I'm quite sure you remember this diagram. So this is one of the example where we got one of this, for example, link AB is termed as link 1, link BC is a link 2, and link CD is 3, and link AD is a 4. So what we are doing here is the AD is the link which rotates continuously in this one, and then it converts this rotary motion from here to this point C, which is basically a oscillating. So you see, it is not necessary that the this link 4 turns continuously, but link 2 doesn't make any turn. Rather it just oscillates within these positions basically. So we have already discussed the kinematic chain is a combination of four or more kinematic pairs such that the relative motion between the links or elements is completely constrained. So this is one of the things which we have just discussed briefly in last lecture. So the completely constrained motion is the one basically where you are able to get a definite motion. So for example, this is the link where we are getting a definite motion. For example, link 4 rotates and link the pair C, the point C is basically oscillating. If let's say you have combination of links in such a way that the motion is not constrained, we have done some examples in last lecture where some of the mechanisms, when you solve it, you find it that they are not really completely constrained. So if they are not completely constrained, we are unlikely to get any useful work from them. That's what we have the understanding. So in this 4-bar chain or quadratic cyclic chain, the relative motion is in as such the motion is basically completely constrained. So basically we are getting some useful work. The simplest and the basic kinematic chain is a 4-bar chain or quadratic cycle chain. This is one of the very fundamental shown in figure 5.1. So this is the same figure. It consists of 4 links. Each of them forms a turning pair at A, B, C, D. So you see, at each particular point, we are making a turning pair. So this is turning pair. Turning pair means the links are, so let's say at this point A, link AD and AB are making a complete revolution, or even if it's not complete revolution, but still is like the angle is changing. So whenever you got some angular movements at these points, we will term as it as a turning pair basically. I hope you remember. So the 4 links maybe, so we got this turning pair on each point basically. So you got like at each A, B, C, D point, this is turning pair. And then according to Groshev's law, for a 4-bar mechanism, the sum of the shortest and longest link lengths should not be greater than the sum of the remaining 2 links. So this is we have done some good examples from Groshev's law, uh, which was very simple. You need to do sum of shortest and longest link lengths. Yeah, so you find sum of shortest and longest link. For example, here the link 4 and if I say because if we know actual lengths, then we know which is the longest. Let's say we got 2 as a longest. So what does it mean? Link 2 plus 4, you sum both. Length should not be greater than the sum of the remaining 2 links. And we have seen this Grosh's law did the definition like this: should be less than and equal to sum of other 2, which is 3 plus 1. So Grashev's law was very useful law to find out if the link will or if the mechanism will do any useful work. So, and what was the condition? Very simple. Sum of shortest and longest link must be less than equal to the other 2 links, sum of other 2 links. So, if there is to be continuous relative motion between the 2 links is required basically. So a very important consideration in designing a mechanism is to ensure that the input crank makes a complete revolution. So this was also the theme of Grashov law. So the link 4, which is the crank, has to make a complete revolution. So a very important consideration in designing a mechanism is to ensure that the input crank makes a complete revolution relative to other links. So of course, this one is making a complete revolution with respect to link 1 and of course with the 3 as well. The mechanism in which no links makes a complete revolution will not be as useful basically. So this is one of the important thing here. The finding the usability of the mechanism, which is done basically by using Grashev's law. And what is meant by Grashev's law means it will tell you if the crank is going to do complete revolution and we are getting any useful work. And of course, one more thing is here. So this AD link is making a complete revolution, but we are not doing 2 link 2 as not a complete revolution. It's just rather making a oscillation from A to C. So it's not necessary that all of the link will cause or will make a rotary motion basically. Uh, just the crank has to do the rotary motion, which of course will be connected with the motor to get a useful work. All right, so now uh, the mechanism in which no link makes a complete revolution will not be useful. Yeah, that's what we discussed. In a 4-bar chain, one of the link is, in particular, the shortest link will make a complete revolution relative to other 3 links. So the shortest link will make a complete revolution with relative to other links basically. So 1 and 3 basically. If it is satisfy the Groshev law, such link is known as crank. So this is the terminology for 4-bar chain. We have discussed, but just a little bit of revision. So such link is called as a crank or a driver. So you got this AD link. This is called as a crank because it's making complete revolution, or it can always be called as a driver as well because we connect this one with a motor to make it complete revolution. So in figure, AD link 4 is a crank. The link BC, so this link BC, which is a 2 here, which makes a partial rotation or oscillation, is known as lever. So this is a different terminology. So we got this link as a lever, a rocker, or a follower. So all 3 names can be used. Uh, and the link CD, which is 3 here, which is basically connecting, which connects the crank and the lever, is called as a connecting rod or coupler. So in our last lecture, we used this word mostly as a coupler, but this is also called as a connecting rod because this is connecting basically. The fixed link AB is known as a frame. So we have discussed this one. Any link which is fixed will be termed as a frame of the mechanism. When the crank link 4 is the driver, the mechanism is transforming rotary motion into oscillating motion. So pretty much this example where you got link AD making a complete revolution, and then the C is basically is causing it in oscillatory motion. All right, so continuation of that. Now we are discussing the inversions of 4-bar chain. So we got the beam engine. So this is one of the example. So beam engine and crank and lever mechanism. So this is first inversion of the 4-bar chain. So a part of the mechanism of a beam engine, also known as the crank and lever mechanism, which consists of a 4 links. So we got still 4 links here as shown in figure 5.19. In this mechanism, when crank rotates about the fixed center A. So let me explain this. So what we have, so this one is a crank, the link 2 is a crank. Link 1, most of the time, as we said, we take the frame. So when anything with a constant no movement is a frame. So the crank is this one which moves around this circle, so making a circle basically, which is connected with link 3. This is the connection, which is further connected with the link 4, which is CDE, and this E is connected with the through a piston rod to a piston. So now if you just imagine link AB makes a complete revolution like that. When it's making complete revolutions, link 3 is moving up and down, and then this CDE is basically rocking. So you got like rocking movement, so it's going up and down basically this side. So when it's going up and down, so the piston rod is moving up and down, and hence we have the reciprocating movement at the cylinder. So that's what we are getting here. So again, in this mechanism, when the crank rotates about the fixed center A, the lever oscillates about a fixed center D. So this lever, the link 4, is oscillating against CDE. So it's rocking basically. The end E of the lever CDE, so end of this lever CDE, is connected to a piston rod. It is connected to a piston rod which reciprocates due to the rotation of the crank. In other words, the purpose of this mechanism is to convert rotary motion into reciprocating. So the ultimate goal from this mechanism is to have rotary motion here. Means how we are getting rotary motion here from through connecting with the motor, for example. So you got a rotary motion here and then you got a reciprocating motion over here. And this all is being done by using 4-bar linkage. So that's why it's called one of the case, and which is quite famous. We called as a beam engine, or sometimes called as a crank and lever mechanism as well, because it involves one of this lever here, and you got one of the crank here. So that's why it's called crank lever mechanism. So this is one of the models shown here. Basically, it's one of the beam engine. I'm quite sure you might have seen this beam engine for oil and gas sector, where for the oil exploration we need quite high pressure to get oil from the ground, and these kind of oscillations or beam engines are used for such purpose. um, so we got here one of the animation as well, which would help you to have better visualization. So you see this bar, this crank is moving, making complete revolution, which is connected with the with link 3. So this is link 3, and then this is a lever, so link 4, and then we got is connected with the connecting rod then to the piston, which is in the cylinder. Basically this is assembly. So this is required for the oil and gas exploration. So if the crude oil is being taken out by using this end, and we got some motor here which operates basically this one. All right, so continuation of that, we got another inversion of 4-bar chain, which is a coupling rod of locomotive, uh, or is called as a double crank mechanism as well, basically. So the mechanism of a coupling rod of a locomotive, also known as double crank mechanism, which consists of 4 links as shown in figure 5.20. So this is like 4 links again. So you got link 1, which is like a frame, acting like a frame, for example, is stationary. Link 2 is one of this BC. Link 3 is this length CD, and link 4, which is basically AD. So now you can imagine this BC and CD, because the both wheels has to be same size. So this BC and AD, so link 2 and link 4 must be of same length, because we are like connecting these ones. So what is the purpose of this coupling rod for locomotive? So we are transferring the rotary motion from one wheel to another wheel, basically. That's what is basically the aim of this mechanism. So the wheels are connected through this rod, basically. So in this mechanism, the link AD and BC having equal length. So these are equal length, so both are cranks, act as a crank. Why we are saying 2 cranks here? Because both are making a complete revolution. So this was making complete revolution, this one making complete revolution. Are connected to respective wheels. The link CD acts as a coupling rod, CD acting as a coupling rod, and link AB, basically link AB is a fixed in order to maintain a constant center to center distance between them. Of course, the wheel has to be kept at a constant distance. So this mechanism is meant for transmitting rotary motion from one wheel to other wheel. This is also quite popular mechanism which has been available in locomotive. We still have same some of the mechanisms like that available. All right, so The next category is Watt's indicator or double lever mechanism. So they are the same name is basically for such mechanism. So what it says, a Watt's indicator mechanism, also known as Watt's straight line mechanism. So this is important thing here. The straight line. This is either you call it as a Watt's indicator mechanism or Watt's straight line mechanism or a double lever mechanism. This is another name, which consists of four links also. That's why we are talking about four bar chains basically. This is shown in figure 5.21. So this is a figure. The four links are, so what are the links? Uh, Fixed link at A. So you got this one as fixed. This just this part is a link one, which is a fix. Link AC. This is another link AC. This is another link which is basically link two. So this is another link. Link CE. So you got link CE. This CE. This is another link and link BFD. So you got BFD. So you see this is called as a link 4. So this is interesting to see. So link BFD apparently looks like we got a two links, but not, because the angle between them is not changing. So basically there is no relative motion between BF and FD. So that's why this will be called as a link 4, as a one single link basically. So it may be noted that the BF and FD form one link because these two parts have no relative motion between them. So in last lecture we have discussed the links are called independent links when they have the relative motion between each other. So of course when they are not making any relative motion, so BF and FD are not making any relative motion, so that's why they will termed as one of the link basically. The link CE and BFD act as a lever. So the link CE, so this one, and BFD. So these two are called as a lever. So that's why this is called as a double lever mechanism as well. So this is one of the mechanism, one of the lever, and BFD is another lever basically. The displacement of link BFD is directly proportional to the pressure of gas. So BFD, which is like connected with this piston, so it is connected through, the movement is directly proportional to the pressure here. So this is indicator plunger and indicator cylinder basically. This is one of the cylinders, so this is the pressure. The plunger moves up and down. So plunger is just like a piston. It can move up and down. And of course, this up and down movement is directly proportional to the pressure of the gases over here. So that's what it says, the pressure of gas or steam. It could be steam as well, which acts on indicator plunger. On any small displacement of the mechanism, the tracing point E at the end of the link CE traces out approximately a straight line. So you see, this is very interesting. So when this moves up, so the other position is shown, the next position. So if it moves up because of this pressure, so you got the link AC is now AC prime. So this is new link, and the position BFD would remain same. So that's why it will be still be same. And link CE is moving upward. So now you see the point, this point, the point E actually has now covered a linear distance of E dash, and then you got like the straight line movement. So that's all we are having from here. So that's why this is called as a straight line indicator, basically straight line mechanism. So we got this movement up here. So also we got some complex system here, but we are getting a linear motion upward, traveling from E to E prime. So that's what we have this Watt's indicator mechanism. So double lever mechanism basically. So this was there. These were three different inversions of 4-bar chain, which we have discussed. But of course, in our last lecture, we had a fourth inversion as well. But as I said in the beginning of this lecture, so we among those different mechanisms, we are talking about or discussing the mechanism which are more relevant for the practical application point of view. So that's why this lecture mainly discusses some of those, not all, basically. So so the next one is the slider crank chain mechanism. So of course, this was also like a 4-bar mechanism, as we discussed last time. But here we are just using in a different classification. So that's what we are doing here. All right, so that's what we have here. Yeah, so single slider crank chain. A single slider crank chain is a modification of the basic 4-bar chain. So you see, it is basically modification of the 4-bar chain. It consists of one of the sliding pair and three turning pair. We have discussed quite in detail last time as well in last lecture. So sliding pair and three turning pairs. We got like individually these ones. So it is usually found in reciprocating steam engine mechanism. So this type of mechanism converts rotary motion into reciprocating motion and vice versa. So let me explain here again. So we got the link one, which is frame. So this is constant. This is link one. Link two is a crank. That's the link two basically. So which is moving in a complete revolution like that. And this is connected with the connecting rod, which is a link three, and the link four is a crosshead. So this part is called as a crosshead, which is basically just reciprocating to and fro movement. And these are the guidelines. So last time what we discussed, we had a cylinder directly over here basically. So we got a like piston moving in a cylinder here, but now this is like a crosshead, and then which is further connected with a piston, and which is moving in the piston in the cylinder, which is this is called as a piston rod. So this is a little bit different version of that 4-bar link. And so so now we are doing, we are getting rotary motion over here, and when it's rotary motion, so it's pushing this one, the connecting rod, and then which is moving the crosshead, and then of course we are getting on some movement on the piston, which is reciprocating. So in a single cylinder, so we are differentiating here with the single cylinder because we will have next example for double cylinder as well. So single slider crank mechanism, as shown in figure this one, the link 1 and 2. So this link 1 and this is link 2. This is link 1 and 2 are making a turning pair. Link 2 and 3, link 2 and 3, they are also turning pair because they are rotating against each other. And link 3 and 4. So now link 3, this is link 3 and link 4. This is also turning pair because it's just like the angular movement, for example, alpha is there. While the link 4 and 1, so link 4, this link 4 and with 1 is just doing the reciprocating movement basically from a sliding pair. The link 1 corresponds to frame of engine, which is fixed. So link 1 is frame, which is fixed. Normally, whatever the link is fixed, we call it as a frame. The link 2 corresponds to the crank, link 3 corresponds to the connecting rod, link 4 corresponds to crosshead. As the crank rotates, the crosshead reciprocates in the guides, and thus the piston reciprocates in the cylinder. So that's what we have here. All right, so we will just continue with this one with the different inversions. So first case is the pendulum pump or bull engine. So this is the first inversion of the slider crank mechanism basically. So in this mechanism, the inversion is obtained by fixing the slider or link 4. So within this one, so if you see what's happening basically, so you got cylinder, uh, which is a link 4. This is stationary. This is cylinder link 4. You got one of the connecting rod. You got crank. So this is a crank. And then we got a piston rod, which is directly the longest link, which is connected towards the piston. So this is cylinder. This is cylinder. So that's why we got two link 4 as a two times basically, because both are stationary. Yeah. So what it says, the inversion is obtained by fixing the cylinder or link 4. So the cylinder is now fixed. In this case, when the crank link 2, so this crank link 2 rotates. So now just imagine it's rotating like this, basically. Yeah, rotates the connecting rod, this one, link 3, oscillates. So you can just imagine when it's rotating like this, of course, this link is just oscillating like this. So that's the movement the connecting rod is basically doing. The duplex pump, which is used to supply feed water to the boiler, is used to convert reciprocating motion into a rotary motion. So this pump All right, so uh, yeah, so basically, so one of the example which is given is a duplex pump. You might have discussed a very brief about this in the boilers. So feed water, the feed water pumps are used for the boilers, where the two pistons are attached to link 1 basically. This is as shown in the figure. So if you just Google it, I am quite sure you will able to find this some of the examples, the movements basically, because they are available. So this is one of the inversion basically for single slider crank mechanism. Now the second category for single slider crank mechanism is oscillating cylinder. So this is oscillating cylinder. So you got one of the connecting rod which is fixed, uh, and then the crank which moves like this way, and then you got a piston rod which is of course like moving up and down within the cylinder, which is connected with the piston, and you got the cylinder itself. So the arrangement of oscillating cylinder engine mechanism as shown in figure 5.24 is used to convert reciprocating motion into a rotary motion. So the purpose is still same. You got a rotary motion and you're converting into reciprocating. So so this time is a inverse. So we are converting reciprocating motion into rotary motion. So this one, when it's move up and down, basically, it will help to move this crank basically. So in this mechanism, the link 3 forming the turning pair is fixed. Link 3, which is forming a turning pair here as well as here, basically, is forming turning pair is a fixed basically. The link 3 corresponds to the connecting rod of a reciprocating steam engine mechanism. When the crank link 2 rotates, the piston attached to the piston rod link 1
So this one reciprocates and the cylinder 4 oscillates about a pin pivoted to the fixed point A. So now you just imagine here. So this one, basically this cylinder is also reciprocating up and down. So this is like oscillating. So you can just imagine if the piston has to move up and down within this one. So because it is further connected here, so this if let's say this goes over here, for example, this crank goes over here. So now you can imagine this will be in this position. And if it's this position, this piston has to be in this position, which is this one. So basically little bit more straight. So this piston is doing oscillation up and down basically within this. So that's why it's called oscillating cylinder engine. So we got a reciprocating movement because why we are calling it as an engine, because we are converting the reciprocating motion into rotary motion. That's what the engine does actually. So you got a piston as a reciprocating and then rotary on a crank, which where you get the movement. So, but here the cylinder is also making a rotation, so it's oscillating basically. So this is one of the example. So this has been shown here. The rotary, sorry. So this was the oscillating one of the example. The further extension of this, what we have is called as a rotary internal combustion engine. This is another example, or Gnome engine basically, one of the name. So if I say this oscillating cylinder because it's just moving, so this is another inversion. So what it says, sometimes back rotary internal combustion engines were used in aviation. You might have seen this in the in the old aircrafts where you got such assembly. So this is like three cylinder. Normally they were quite a lot of cylinder like this basically. So you got one, two, three, four, five, six, seven. So you got seven cylinders, for example, in rotary engines for aviation in all old cases. But nowadays gas turbines are used. So this is one of the like thing which has been obsolete in the previous aircrafts just because of the high weight basically. So you just imagine seven, eight cylinders are attached on aircraft. So the weight of such engines is really high, and the gas turbines are really low. If you convert or compare the power to weight ratio, basically, so gas turbines are much better. So it consists of a seven cylinders in one plane, and all revolves about fixed center D. So this is the fixed center D. So they all revolve around this one as shown in figure, while the crank link 2. So this is the crank. So this little bar here, this is the crank. So this is basically rotating around this fixed center basically. Rotates the piston. So while the crank link 2 is fixed in this mechanism, uh, when connecting rod link 4. So the connecting rod link 4, so this one. So you see we got one of these connecting rod, this is also connecting rod, so two cylinders are connected together basically like that. uh, Connector link 4 rotates, the piston link 3 reciprocates, so this one reciprocates basically inside the cylinder, forming link 1 basically. Yeah. So I think I got one of the animation which shows very clearly the next one. Yeah. So this one is a very good example. You can literally find out more examples for rotary engines where you got like the such combination. Uh, just a minute. Yeah. So this is the operational. So you see the crank is making complete revolution, and the connecting rods are connected in such a way that you got the combustion and then you're getting the rotary motion over here. So that you have the combustion on cylinder which pushes this connecting rod. When it pushes, then it causes the crank to move. And of course, because of typical multiple cylinder engines, you got uh, different working cycles on each cylinder. So in one case, let's say if you have the power stroke here, So if it's a power stroke over here in other cylinder, you will have some compression stroke. So basically they are helping each other. So that's what the principle of this rotary engine basically. Yeah. That's it for this one. So we'll continue with this with the next lecture basically.